Welcome to week 2. We're going to start with assignment 6, but before we get started, I want to talk about turning stuff in real quick so that we can all get on the same page. So some people have been printing out and writing on their assignments. Some people have been taking pictures. Some people have just been doing it on notebook paper and turning it in. But what's really important over how you do the work is that if you look at the screen real quick, you can see that there's tons of options for a JPEG to PDF converter or GIF or whatever format, if it's PNG, whatever format your picture's in, you convert it to PDF and compile it into one big PDF. That makes it easier or possible in some cases for us to read and grade your assignments. And sometimes we just can't view it or can't see it, and we really need you to submit one PDF for the whole homework assignment. So don't forget, every Wednesday you need to check Math 0314 for submitting your discussion board post and responding to someone else's discussion board. And then be checking on the assignments for their due dates. Sometimes they'll be on Wednesday, sometimes they'll be on Friday. It's really important that you check the due dates of each assignment so you know when it's due. And on top of that, we also have a test this week. It's a big, we'll have an extra day, a blank day for review. I'll post a little bit longer of a review video. But it's really important that you take that test seriously and that you prepare for it by looking at the past videos, by looking at all the assignments you've done, looking at the ones you missed, and really look at that review once we get it posted. So let's get started on assignment 6. If you have any questions, come see us in office hours on Tuesdays and Thursdays, or reach out to us via email and we can set up a Zoom. So here we go. We're going to start with factoring out a greatest common factor. Factors are things that multiply to get other things, right? So we're going to look at each of the cases individually. Remember, the only invisible sign ever is multiplication. So we got invisible multiplication signs everywhere. And we're just going to ask ourselves, well, what are the factors of each individual term, right? So the first question is, what is the greatest factor for 28 and 49? Well, does 28 go into 49? Multiply it by 2, you get not 49, something maybe 56? No, too big. So we got to think, okay, what about 14? Well, 14 is not going to go into 49 because it's even. So we keep working our way down and we just think our way up the factor tree. If you remember breaking down factor trees from a long time ago, and eventually we'll get to 7. We'll say, well, 7 goes into 28 4 times and 49 7 times. So that makes a lot of sense. So what I'm going to do is I'm going to pull out a 7 from both constant terms, right? So it's like factoring out a 7. And I'm going to say 7 outside of whatever goes in the middle. I'm going to make that a little bigger. And then I'm going to say, okay, well, what about the x's? How many x's can I pull out of this side? I could pull up to 3 out of the left side. And how many can I pull out of the right side? Only 2. So the greatest common factor there is 2 x's that can get pulled out. So we can pull out an x squared. And then we look at the y's. How many can we pull out of this side? Only 1, which means we can only pull 1 out of that. It's kind of like if you remember chemistry, how that idea of a limiting reactant, like whatever's the smallest reactant or the least amount of those exponents, that's the one we're using. So, and then we're left with whatever's left on the inside. So if we pull a 7 out of 28, we're left with 4. If we pull an x squared out of an x cubed, we're left with x. And if we pull a y out of a y, we're left with no y's left on the left side. Leave the minus sign alone. We pulled a 7 out of a 49, leaves us with a 7. We pulled an x squared out, leaves us with no x's. And we pulled a y out, leaves us with y squared. Cool? Have any questions? Let us know. But that's how you kind of go about thinking about greatest common factor. Is you're looking for the biggest number or biggest variable that you can pull out of both sides. Not just one side, it has to come out of both sides. It's like reverse distribution. If you think about the distributive property, when we've talked about that in other videos, where you have an x going into an a and a b, and you're distributing it, the greatest common factor of factoring something out is like the reverse of that. It's when you pull out something common. All right. Let's look at a grouping. Okay, so some of these are you have to factor by grouping, and some you don't have to factor by grouping, but it makes it easier when you can see the process, right? So if we're looking at number 8, we could combine like terms, put that 4x and the 3x together, make a 7x, and do it in the basic factoring way, which we'll do later in problem 16. But first I want to show you some factoring by grouping, the method where we put parentheses around 2 distinct groups. If that was a negative sign, important note, if this plus was a negative sign, we would have to include it inside, but it's not a negative, so we're going to leave it alone right now. And what we're going to do is we're going to just factor again. We're going to say, what's the greatest common factor for each of the red blanks? So I can pull out of the first term and pull out of the second term. There's no numbers that they don't have a common. The greatest common factor for the constant is a 1, because 1 goes into 1 and 1 goes into 4. And the greatest common factor for the variable is probably just 1x. So if we pull out 1x from the left side, we're left with x. And if we pull 1x from the right side, we're left with 4. And if you want to check yourself, you're like, I don't know if I factored right, just go ahead and do that distribution like we talked about. Distribute it and see if you get the same thing back. And you probably will. Cool. So then what about on that right side of the plus sign? So I'm going to leave that plus sign alone. I can probably pull out a 3. And if I pull a 3 out of both sides, probably going to end up with something like 3 times x plus 12 divided by 3 is 4. Again, if you don't know or you're unsure if you got it right, redistribute it and check and see what happens. And then what we're going to do is something really cool. We're going to take this blue term and this red term, that red term and that blue term, and they're going to make a new term on the left. Well, it don't matter. Multiplication's commutative. But they're going to make a new term together. So that blue term and that red term are going to come together and make x plus 3. And then the term on the right basically gets factored out. So what's really happening is we factored out the x and factored out the 3, and then we're going to factor out the x plus 4 from both of those terms. So we're left with the multiplication of x plus 3, x plus 4. Make sense? All right. Again, you have any questions? Let us know. We'd be happy to help. I can draw that last factor step. Basically what we did is we factored out a common x plus 4 from that whole thing to see that we were only left with x and plus 3. Cool? Okay, last one. We're going to look at this normal factoring back from like 9th grade when you learned factoring for the first time. And when you learned factoring for the first time, you probably made something like a factor tree where you had to decide what terms multiply to give me this last number, right? So we probably said, what terms multiply to get me 6? Well, 1 or negative 6. That's an important negative sign right there. So probably 1 and negative 6, negative 6 and 1, 2, negative 3, negative 3, 2. And if you can think of any more, you add them. But those are the only ones I can think of, the multiples of 6, where the middle term multiplies to get you that negative 6 term. And then we ask ourselves, well, which of those sets add up together to get you that middle? So as a quick note, they have to multiply to get you the last term, or the C term, and they have to add to get you that negative 5. So when we look at all these terms, we're going to add them. So we already multiplied them to check for the last term. Now we're going to add them together. So what is negative 3 plus 2? Well, if we add those together, that gets us negative 1. That's not it. What about negative 3 plus 2? Oh, those were the same thing. I should have put a negative on that 2. There you go. 3 minus 2. If we add those together, probably gets us something like 1. Nope. What about, I did it again. I should have, there you go. That fixes it. The negative's got to be flipped on the terms. Otherwise, it's writing the same thing twice. So we got negative 1 times 6 gives us, negative 1 plus 6 gives us 5. Is 5 the middle term? Nope. And negative 6 plus 1 gives us negative 5. Holy moly, there it is. So there's our two terms, or our two factorable terms. So what we're going to do is we're going to rewrite this knowing what the first term is, because x times x is going to give us that x squared, right? And now we've got our two second terms, which will be minus 6 and plus 1, and you are done. That is factoring. If you don't remember or you don't 100% like your answer, what you can do is you can use the FOIL or the box method, which there's a video to go check on, and you can first, inner, outer, last, that FOIL method that we've talked about before, or that you probably remember from dreading in high school, and you can check and see if you like your work. Cool. So thanks for watching. Keep working through the rest of these problems. Make sure you check those due dates. Make sure you prepare for your final, or your exam 1 that's coming up this week. And make sure you look at our announcements as we start this second week. Thank you. Bye.